Okay, class, welcome back. If you have ever looked at a water bottle you get from the store, you can see at the bottom there are several units of measurements of the volume of that bottle. For example, a bottle might say 23.7 fluid ounces, or 1 pint 7.7 fluid ounces, or even 700 milliliters. We all know this tells us how much liquid is within the bottle, but why are there so many units? Well, the short answer for this is people measure substances in different units. Some people may use fluid ounces, while other people may use milliliters, while some people might even just use pints. This can be problematic, though, when it comes to science, if one person is talking about a substance in ounces and another person is talking about a substance in milliliters. Because of this, there need to be a standard set of units to compare scientific data. These units are called SI units, and my objective for you today is that by the end of the video that you would be able to identify and convert between different SI units. And saying that, let's dive into this video. Because scientists need to report data that can be reproduced by other scientists, there needs to be a standard unit of measurement that is universally accepted among the science community. This is where the system of international units come in. We call these the SI units, and for short, it revolves around 7 base units, which would represent the type of substance being measured. The technical definition for a base unit is the unit in a system measured based on the object or event in the physical world. The 7 base units in which we revolve our data around are the following. For time, the unit is second, which is represented by a lowercase s. When measuring length, we use meters as our SI unit, and it is abbreviated with a lowercase m. When measuring mass of a substance, we use the kilogram, or kg for short. The SI unit for temperature is Kelvin, or K. When measuring the amount of substance we use, moles, or mol, are used for short. Our 6th unit is for electrical current, and that is an ampere, or a capital A for short. Our final SI base unit is for luminous intensity or brightness, and it is known as a candela, or CD for short. To better describe the range of possible measurements, scientists have added prefixes to base units. These prefixes can add onto any base unit and mean a significant quantity of that substance. For example, kilo means 1,000, so 3 kilograms means 3,000 grams. This prefix can be used to represent a large or small unit depending on the prefix. For example, we said our kilo means 1,000 from earlier, but if we change that prefix to milli, that is saying that that substance is 1,000th of that unit. So 3 milligrams would be 0.003 grams. As in this case, we can see prefixes make a big difference. Here's a list of prefixes we use in this class. The prefix giga is represented by the uppercase G and means 10 to the 9th, or a billion. So 1 gigagram is 1 billion grams. Our next prefix is mega, which has a prefix of a uppercase M for short. It represents 10 to the 6th, or 1 million. So 1 megameter is 1 million meters. As we continue to work our way down, the prefix kilo, we said, means 1,000. And that is with a capital K. We continue down, we see a hepta with a capital H means 100. And a deca with a capital D means 10. That takes care of everything bigger than our base unit. Now let's work our way down to substances smaller than our base unit. A deci is represented by a lowercase d and represents a tenth of a substance. So a decimeter is 1/10 of a meter, or 0.1 meters. Centi, or a lowercase c, is represented by 100th, or 10 to the negative second. So 1 centimeter is 0.01 meters. As stated earlier, millimeter, or milli, is represented by a little m and represents 1,000th, or 10 to the negative third of a substance. After milli, we go down to micro, where it is represented by the following symbol. and it represents 10 to the negative 6th power of a base unit. So 5 micrograms is 0.000005 grams. Our last two prefixes are nano and pico. Nano is abbreviated with a lowercase n and represents 10 to the negative 9th base units, while pico is our smallest unit and is represented by a lowercase p. The pico prefix indicates there is 10 to the negative 12th base units. So temperature is the quantitative measurement of the average kinetic energy of the particles who make up an object. There are 3 units used worldwide to represent temperature. They are Kelvin, Celsius, and Fahrenheit. As I've said previously in this video, we are in the science world, so we are going to convert everything to Kelvin. So here's how we convert temperature to Kelvin. If you're given something in Fahrenheit, you are going to have to convert to Celsius, then to Kelvin. So our formula to go from Fahrenheit to Celsius is degrees Fahrenheit minus 32, all that divided by 1.8. So if I wanted to convert 35 degrees Fahrenheit to Celsius, I would subtract 32 from it and divide by 1.8, which gives me 1.7 degrees Celsius. Hypothetically, if I wanting to convert from Celsius to Fahrenheit, all I would have to do is take my Celsius and times it by 1.8, then add 32 to it. So if I had a temperature of 35 degrees Celsius and plug it into my equation, I would get a 95 degrees Fahrenheit. Once you get your temperature Celsius, in order to convert it to Kelvin, all you have to do is add 273 to it, and you will get your degrees Kelvin for a substance. Our last topic for the day is we need to understand that not all quantities are measured with SI base units. For example, an SI unit for speed is meters per second. Okay, so we've seen this primarily whenever you're driving, you see miles per hour. These are what we call derived units. Okay, so notice it says meters per second. So that's 2 SI units, the meters being the first one and the seconds being the second one. By combining these base units together, we call these derived units. Outside of speed, there are 2 derived units in which we are going to commonly use, and they are for volume, which is cubic centimeters, or density, which is grams per cubic centimeter. Okay, I feel that's enough for today. Today we covered the base SI units and their prefixes. We also discussed how to convert temperatures and what derived units are. Keep up the good work and see you next time in class.